So today I'm going to talk about the basic structures, and I'm going to talk about we have basically three angles and three parameters. We can say six parameters in our crystal lattice. So let's discuss about it. When we talk about not about lattice, let's take a one unit cell and discuss it because that's exactly the same arrangement throughout the atom. So that we can draw it left for a while. Let's just erase it and draw it with the help of a with this with shapes. So let's take the shape of square. And one more I need the process. So like that. Yeah. Oh, it's perfect. It's just perfect. I need a perfect color just to draw it. So let's just make it one from here. Something like this. Okay. And then again, yet something like this. Something like this. This is a one in itself. For a while, consider. And something like this coming from the back. I don't know it's beginning. So, yeah, we can consider it. I don't think so. It's making a perfect structure, which is difficult for me to explain it. Let's consider it. Making myself here. I'm just creating myself here. So be easy for you to understand. Something like this, and then drawing one more. Something like this, joining this to this. Okay, something like this, and yet again like that. It's almost done. So let's use a different marker just to highlight what exactly I want to say. Let's take a blue color is not highlighted. So let's take for a while consider that this is basically known as edge, right? And each unit cell has three edge and three angles. Three edge and three angles prominent. It's prominent. Three angle. If we talk about primitive unit cell or a simple unit cell, there are three edge and three angles. This is known as alpha. And don't say it. You can shuffle like you can write alpha or beta or gamma here. It's just prominent or not prominent, but it's fixed that you have to write beta, and this is known as gamma, right? This is named as gamma. So this is a prominent side where we know the side that is opposite to gamma is we could say its gamma is C. Opposite to beta we have B. Opposite to alpha we have A. So between C and B we have alpha. Between C and B we have alpha. Between B and A we have B and C we have gamma, or B and A we have beta. B the angle between that we have between C and A is beta. C and A is beta. So I'm repeating again. The angle between A and B there we have is gamma. The angle between A and B is gamma. Then angle between ACB is alpha, and angle between AC is beta, but that were exactly fixed. Right, so this is basically something that I have explained right now. And then let's erase it and let's just discuss it with the help of diagram. But I don't think so it is perfect to discuss because the diagram is so messy and yet it's not perfect. So let's take an example of a crystal lattice with have that I'm going to explain each and everything in its cells and the corners and each and every calculation that we need to understand before dealing with the structure of the initial crystal lattice. I need to get here crystal lattice. Okay, let's take example of crystal lattice here. Okay, let's take example of crystal lattice. Okay, let's take this example here, crystal lattice. So now I'm going to discuss here what is crystal lattice. This is known as lattice point, and this is a crystal lattice, and each this one circle representing a one unit cell. And this is basically a proportional lattice point, so one constant particle is situated here or located here. You can't say that this one particle is participating with all over the unit cell. No, only 1 upon 8 part is participating with this unit cell. Only 1 upon 8 part. How we can prove it as well? For instance, we know this is a 3D structure, so one 3D structure is located here as well, something like this. Okay, one 3D structure is located here as well. One 3D structure is located here as well. One 3D is located here. So 1 by 8. This one constant particle is participating with 8 other particles here. 8 is a particle. So this is one constant